Hi guys, thanks again for enrolling in our course on the mud crab vertical farming. In the previous lecture, we have shown you the different production methods that are commonly used to produce mud crabs, from wild catches, ponds, vertical farmings for soft-shell crabs, as well as vertical farmings for crab fattening. In this lecture, we will be discussing the typical mortalities for each of the systems and each of the specific technologies that are being used for mud crab production. Your profit. It is important to take note of the mortality of the farming technology that you are using, as your profitability will greatly depend on this factor. As you will see in subsequent lecture, mortality is one of the very sensitive parameters that will actually change or make your It is important to take note of the mortality, as your profitability will depend on one key parameter, and it's very sensitive on mortality. Essentially, the mud crab trade is a live one, meaning a live crab is worth 80 ringgit per kilo, and when it's dead, it is usually worthless. Before we start off to look at the mortalities in vertical farms, let us first look at the typical mortalities if you were to experience a pond-based farming or even what we call traditional conventional methods. In ponds, the key factor to reduce mortality is what we call stocking density. As you increase the stocking density, what actually happens is the crabs will have a higher chance of encountering each other and therefore resulting in cannibalism. Typical stocking density can be up to 0.5 to 1.5 crabs for every meter square. And with this kind of stocking density, mortality can be as high as 67%. If you are stocking up to 0.2 crabs per meter square, you can sometimes have a mortality of 85%. Or in other words, survival rate can be 15%. However, survival rates from 20 to 86% has been reported in mangrove pens, but that depends on different stocking density. So what we have here is extracted from one of the papers. This is the name of the paper. As you can see that if the crabs are being grown in what we call the mangrove pens, which was discussed earlier, by sort of netting off a specific section of the mangrove forest in which you will stock your crabs, survival rate is only approximately 31%, which is mortality is about 69%. However, if you start to put them in cages, you can see that the survival rate increases up to 53%. So this is probably due to the fact that the crabs are being isolated from each other and hence reducing cannibalism. Further breaking down the typical mortality that happens in a pen culture. So what happens generally is you're going to have 20% of crabs that will escape from your system, and about 22% is attributed to what we call cannibalism, either by cannibalizing each other during the hard shell stage, or whereas it can also happen in another way by crabs that are cannibalizing on crabs that are currently molting. So one good way to reduce cannibalism during the molting process is to provide them with adequate shelter so that the crabs can actually hide and perform adhesis. You can also see other factors will contribute about 10% to the overall mortality, and this is also another important point: molting weakness and molting difficulties. As we have discussed earlier, molting is a very complex process, and we can see that 22% of the overall mortality is attributed to this point. If we were to look at the vertical farming system as compared to the pen culture or the pond culture, what you are essentially removing by using vertical farming is only the cannibalism. It is often very hard to change the molting weakness or molting difficulties because that is the inherent mortality in the process. By managing your vertical farming system well, by ensuring everybody closes the doors to each of the crab houses, what you can also ensure is to reduce the amount of escapees that are being farmed, because essentially crabs are very prone to escape from your system, and that is also evident if you're even using vertical farming as well. So what is our mortality when you're trying to farm crabs in a vertical farming system? So this is the mortality result that we had a while back. So it's what we call mortality root cause analysis. So similar to the previous findings, molting failures is accounting for about 20%. So this is what we call the inherent molting failure that the crab faces when they're growing out in the system. However, there are also other sort of subsets of reasons why the crabs are dying in the system. For example, 21% is due to what we call lost limbs. So when we first started out the system, we didn't have a very good knowledge on how to run your water quality. So when you have a deteriorating water quality or your water quality is fluctuating too much, usually what happens is the crabs will tend to lose out their limbs and they eventually die. 29% of the time, we are not too sure why the crabs are dying. We sort of attribute this to probably diseases and inadequacy of the system being too small for the crabs. Another big portion of a mortality in our system is what we call TM, which we categorize as transport mortality. As you can see, it accounts for 25%, and it's one of the major reasons why mortality is very high in especially a system like us. We will explain a bit more about these individual root causes. And lastly, the smallest part is erosion. And this is probably due to what we call the shell disease that is slowly eroding onto the shell of the bacteria and eventually causing secondary infection and killing the crabs. So start off with molting. These are all pictures that we have accumulated when the crabs are being farmed in the system. So what happens to them is generally they will try to molt. They will try to open up the sutures of their carapace and they will eventually die. So if we were to look at the traditional literature on what constitutes to this phenomenon, usually they will attribute failure to molt due to low temperature or nutritional causes. So in one experiment, it shows that if crabs are held between 27 to 30%, they're usually successfully molted. But if they are held at 20 to 22%, only 17% of the crabs molted in the same period. This is sort of the same as the lobster industry, as one way to induce molting is to increase the temperature in which the lobster are held. However, in our case, we are always farming in about 27 to 30 degrees Celsius. And why are we still seeing what we call failure to molt? It is essentially due to nutritional causes. So we have said earlier on that our boxes are probably too small for the crabs to be able to feed at a high rate. So this is specifically true for crabs that are above 500 grams. As you can see, by putting them into the system, you will see that the feeding rate decreases from about 3 to 2%. This is also evident when you're trying to farm big crabs for about 1 kilo, and farming them in our system can generally result them into feeding of about 1.5%. So one of the biggest assumptions that we have overlooked and most of our clients have overlooked is the space constraint of the box. We have also mentioned earlier on that crabs in the wild, they do move around and forage for food. By enclosing them in such a small area, and this is usually what happens as it manifests as a lower feeding rate. So this is a small chart on the typical molting efficiency and the success rate of the crabs in our system. And note that this data is specific to the crabs that are farmed in our boxes. For more dimensions on the boxes that we are currently using, please refer to the previous lecture to look at the dimensions that we have in our farm. So as you can see, that we first break down the analysis into different weight categories. H0 being crabs from 0 to about 100 grams. H1s are crabs from 100 grams to 200 grams. H2s are crabs from 200 grams to 300 grams. And H3 are crabs from 300 grams to 400 grams, so on and so forth. So how do we calculate the number of molted crabs? So what we use is two variables. Firstly is the molted percentage, meaning out of 10 crabs, how many of them actually molted in the period that we were looking at, and molting efficiency, which is defined as how many of them that try to molt and what is their success rate. So for example, as you can see, for H0 crab, within our window of observation, all of them, 100% of them try to molt. And they have been molting with a success rate of approximately 90%, which gives you an overall success rate of 90%. As we can see, if we move up to the first category, H1, about only 50% of them try to molt. So assuming that you have 10 crabs in the H1 category, from 100 grams to 200 grams, only 5 of them try to molt. And out of the 5, only 70% of them is successful. So that gives you about an average of about 40% success rate. As we move up to higher categories, what we generally see is two things. Number one is, at the same period, the amount of molting decreases and the efficiency also decreases. So if you will try to farm a crab that is farming from 300 all the way to 700 grams, you will realize that your success rate is only about 3 to 5%, trying to get them to molt from 300 to 500 grams. At this very low success rate, it is not likely that you can achieve a profitable business. And hence, what is our recommendations? So if you are either trying to use the same box, we would only suggest you to try to do a grow out maybe up to maybe H1 size, in which after the molt there will be somewhere between 250 to 300 gram size, very close to the marketable size. The marketable size is about 300, so essentially you're going to need maybe H2, which is a 200 to 300 gram size. After that molt, there will about be 350. So the other way to solve this problem is to try to use a bigger box. The next one of the biggest mortality that we have in our system is what we call transport mortality. Crabs are known to be what we call an aquatic species, but however, the industry do not transport them as such. The crabs are always transported in a dry environment, meaning they'll pack them in styrofoam boxes and send them through different countries. So if you are running even an export market, usually your crabs will have to be sent from, for example, India to Singapore via air flight. And due to the transportational cost, people tend to pack them in dry boxes and without any water. This is to reduce the weight and in return reducing the logistical cost. However, if you were to take out a crab from its aquatic conditions onto a dryland conditions, they are able to survive, but not for a prolonged period, probably to 6 to 7 hours. Anything beyond that, usually you will result in what we call the stress that is induced to the animal. And this is one of the major reasons why crabs are so expensive, because it is the mortality that has to be accounted for throughout the supply chain. For example, every time you're packing a crab, you are handling them, you're grading them. As you can see from the previous video, that how evasive is the grading process by pressing onto the shell and sometimes even cracking it. So exposure to breeze is another one. Temperature being too high or too low, or abrupt changes. So apart from air flights, what happens is once the crab gets into the specific country that you're going to, for example in Malaysia, the crabs will land in probably Kuala Lumpur or Senai and is then transported to several other states with bus. And note that they are usually just placed under the boot of the bus, which is really very hot. And also time is another factor to consider. From all the way to harvest and to the market, it can sometimes take about 3 to 4 days, which is really stressful to the crabs. And when they are transporting, usually they'll lose some of their weight due to starvation, and crabs in general will accumulate ammonia in their body, and they will need what we call water to purge out that ammonia that is accumulated in their bloodstreams. So the important factor that we want to sort of remind everybody that is your source is very important. And your suppliers, whether they are dealing with crablets or whether they are dealing with crab fattening or even for trading purposes, they need to know that you are farming them and you're not holding them for only 2 to 3 days. And you can reduce the mortality just by ensuring that the supply chain is robust enough, up to about 30% mortality. So I will show you our different supplier results. So we have here 3 suppliers, supplier A, B, C, that have been supplying us water crabs for fattening. As you can see, supplier C, if I just place a crab 2 days into the system, the mortality is about 60%. Whereas for supplier B, your mortality can only be 37%. But look at supplier A. The 10 days mortality is only about 10 to 15%. So what we are trying to show you is there are all the different crabs from different suppliers, but they're all placed in the same conditions. Why? So why do they vary in terms of mortality in such a great manner? The only difference between supplier A versus B and C is that supplier A have what we call a robust supply chain, meaning at every route of the supply chain, supplier A incorporates what we call a dipping system in which crabs are removed from the styrofoam box and the dead crabs are being removed from the batch, and whatever that is alive is placed into water, being salt water or even brackish water, to let the crab sort of regenerate and recover from the stressful supply chain before sending it to us. So you need to understand what is your supplier doing with the supply chain. All right, they have to make sure that their supply chain is robust and they have sort of a good understanding of the crabs. So what are the crabs to avoid? Generally, you need to avoid crabs that look dehydrated, that have bubbling through their mouth, crabs that are weak, sort of the crabs that have barnacles, which indicates they haven't been molting in a long time, lost limb, broken shells. Broken shells will not kill the crab directly, but usually it will lead to secondary infection. Crabs with parasite, this is what's a rhizophyllum barnacle looks like. Discoloration of shell and shell diseases. Alright, so this is a typical crab that has shell disease. So the bacteria will actually eat onto the shells and perforate the shell, and then you have secondary infection either from fungus or some sort of other bacteria that infects the crab. Shell with discoloration are also crabs that have accumulated a significant amount of iron by moving across acidic soil. When they have accumulated a huge what we call deposits, it will usually lead to growth retardation and death. So in terms of mortality, this will also constitute to a mortality in your systems. Right, crabs with barnacles this is what that looks like. It basically means that the crabs have not been molting in a very long time. So it's been so long that the barnacles have actually grown onto it. Sometimes if your crabs have a lot of barnacle, it can generally reduce the perception of the product and of course leads to a lower market value. So crabs with lost limb also means that it is probably due to a previous traumatic molt, or it is exposed to too much dry environment. Usually what happens is it will tend to drop off their legs because they are stressful. And lastly is what we call crabs with parasites. So this is a disease that is not very well understood. Essentially, it is and is often mistaken for a female crab. So what we have here is you can see that this is an abdominal flap, and it has what we call that looks like an egg sac. But for those who are more familiar with the crabs, and you look at previous lecture, this is actually not how an egg sac actually looks like. This is what we call crabs infected with rhizophyllum barnacles, in which they convert a male crab into a female and changing their sex organ. So we highly recommend that you do not take in any crabs of any sort that have any sort of parasites, bacteria and diseases, because this is how it will attribute your system to be susceptible to diseases and eventually resulting in high mortality. Right? So that's all for this lecture. In this lecture, we've shown you the typical mortality if you were to farm in a vertical farming system. So the mortality for grower can be up to anywhere 30% to 40%. So you need to look at, and we know that the mortality is size dependent. So one way to avoid mortality in the system is to avoid molting. So how do you do that? So we specialize in what we call crab fattening, in which we buy water crabs, fatten them to up a period in which they are full, and we sell them before they can molt. So for those who plan to farm big crabs in the system, this vertical farming is really only applicable if you are trying to do fattening, as you are trying to avoid the molting process. But if you were to try to do grow out, you are only realistically looking at about the size, about 200 to 300 grams, in which after that, molting would be too costly to incur. Another potential business model is to look at softshell crabs, because softshell crab tends to molt at about the H0 size, which is about 800 to 120 grams. As you know, the mortality there is about 20 to 25%, which is still something that is worth to consider. So that's all for now. The next lecture will look at the supply chain of the business and how the crabs are being transported from one country into another, and how much time you actually spend during the supply chain.